In today's video, I'm going to introduce to you and demonstrate validating admission policy. This is a type of resource in Kubernetes. This single slide here is going to be the introduction, then I'll move on to the command line to do the demo. So, what is validating admission policy? It's policy enforcement on the cluster via matched rules, and it's an alternative to webhooks since version 1.22 of Kubernetes. Webhooks were a lot more complicated. You had to actually create your own application, commonly done in Golang, but can be done in other runtimes as well. It was just a whole load more work just to set up some validation, some policies. So what are the use cases? This will give you a better idea. Lots of different things. Resource management, such as the maximum number of replicas, the ability to force the requests and limits be used. Security enforcement, such as no, you can never use the latest image tag in your manifest. Metadata governance, so you must use a particular specific label, for example. Operational safeguards to stop you deleting resources as one example. Network controls, for example, to block the use of host port. And also, I would say, validation admission policy is not the only way you can do policy enforcement with matching rules. You can also look into particularly Kyverno, Open Policy Agent, and also Gatekeeper as possible alternatives. I won't be covering these, but I just include these for your own reference. You may want to look them up. So with that said, let's have a look now and see exactly how this works. So here we are again on my personal Linux server where I'm running lightweight Kubernetes distribution, kind, single node, Kubernetes cluster. In this directory here, we're looking at three files. The first two we're going to look at are vap and deploy.yaml. So let's have a look at deploy.yaml. And this is nothing more than just a namespace called demo and then a deployment. And the deployment is very simple. I use this for a lot of my demonstrations. It's just the HTTP Echo app, which is just like a kind of test app that's been invented by HashiCorp. And there's some sample arguments and ports, but we're not concerned with those. But you should pay attention to this down here, which is the requests and limits that we actually have set, CPU and memory, both requests and limits. So do remember that, because we will come back to that. That's a clue for the kind of policy that we're going to enforce. Now this is the other file, vap.yaml, and in here is two resources, the validating admission policy, and also we'll look at shortly the binding that is also necessary. So the main logic is in here, and this is saying here that on creation or update of anything that comes out of the apps API group, which is deployments in this case, but I could easily have also put things in there like services, stateful sets, etc. And it's saying that you should do a validation on whatever's in the manifest under spec containers, all this stuff here. This here is a free form text field that I think will trigger when the policy is not met, but it's also kind of useful just to explain what all this kind of might look like garbage at first, but it's difficult to read basically. So all containers must have a CPU and memory requests and limits set, and that's basically what all of that means. Now the other resource, which is the same, just has the word binding after, is required. Let's just move down and see the whole thing. And what this will do is it will just say, you know, on a validation action to deny the creation or update if all of this is not here. But most importantly, the binding is used to not only to apply the policy, but also this is where you might narrow down where it applies to. So this won't be on anywhere on the cluster. It will only be for the namespace demo, because there's a namespace selector and it says here demo. So hope that makes sense. Now before we go ahead and apply any of these manifests, I just want to tell you there is also a deploy bad here, and what I've got here is this is the same as the other deployment we already looked at, but it has no requests and no limits set, CPU and memory. So I've called this bad because it will not obey the policy that we are going to apply. Oh, and by the way, what I referred to as unreadable garbage earlier, I understand is actually CEL, Common Expression Language. I did not write that from scratch. I used the AI to assist me in creating that, but this is something that is a skill worth developing. Now, with that said, let's go ahead and apply this validating admission policy. And there you go. It's created those two resources. It's created the policy itself and also the binding as well. And I've just done a kget validating admission policy. It's quite a long term, so easy to make spelling mistakes. And you can see here, there it is. That's the single one that we've got there. Now let's go ahead and try and create that deployment, which we already know is compliant. We shouldn't have an issue. And there we go. It looks like it was created. I mean, let's just double check this. Just doing a kget pods on the namespace demo. Looks good to me. Only a single replica, a single pod, that is what was in there, and it's running. Everything looks fine. Now, just to save some time, what I've done is I've deleted that deployment that we literally just created, and it was successful. And now I'm going to apply the other manifest, the bad manifest, the one that doesn't have requests and limits set, and let's see what happens now. And there you can see the policies kicked in. The namespace was able to be created, of course, but it's now saying the deployment is invalid. Validating admission policy require resource limits with the binding require resource limits binding denied request. All containers must have CPU and memory requests and limits set. Remember, this was that sort of custom text that was kind of half a comment and half an error message. Quite useful, actually. So you can see this VAP, this validated admission policy, has been successful. It has forbidden us to go ahead and create that bad deployment, that non-compliant deployment. And now I'm going to show you something useful here. So first thing I'm going to do is get rid of this policy. So we're going to do a delete tac F on the manifest, and both the policy and the policy binding were both deleted. And now what I'm going to do is I'm going to reapply the bad deployment. And obviously we expect this to be successful because there's no policy in the way, and that looks good. And just to prove a point, let's just have a look at the pod. The pod is running. There it is. So we had this so-called bad deployment running, the one that doesn't have requests and limits set, but we have no policy, right? We got rid of that, so it doesn't matter. Now what happens if we reintroduce the policy? What's going to happen to what will be now a non-compliant deployment? Let's take a look. You can see that they were both created, but if I do a kget pods on the namespace demo, well, it's still there, it's still running, nothing has changed. And that is actually fine because the policy only applies on create and update. If you remember in the manifest, there it is, just by way of reminder, it only applies when this deployment is being, any deployment is being created or updated. Well, the deployment already existed at the time that we created the policy. Nothing was changing. It wasn't undergoing a creation state or an update or anything like that, and that's why nothing happened. So what I'm going to show you now is something interesting. We're going to edit the deployment bad manifest and reapply it. So basically I want to update this. So the only thing that I'm going to do is I'm just going to change this text down here. It can be anything in here, right? So I'm just going to say hello world. It really doesn't matter. So I'm going to save this. And now let's actually perform this update by reapplying the manifest for deploy tacbad.yaml. And you see what happened here. The validated admission policy is kicked in. It said the same thing as before. Basically, it was denied because all containers must have CPU and memory requests and limits set. So an update was in the process of being performed, but the entire update was denied because obviously it doesn't comply to the policy. It doesn't matter that we weren't editing anything to do with requests and limits. That's besides the point. Whilst we were doing an update, which is one of those things, as well as create, that was listed in the VAP manifest, then that's when the policy will take effect. And it did that successfully. So that's it. I hope you found this video interesting. I hope you learned about validated admission policy, and from the demo you can see exactly how it works. There are lots of easy quick win implementations that you can do right now in your company, implement in your cluster, and a lot of people will appreciate that. Policies are always a good thing. A few are good, maybe too many can be bad, but a few are definitely good. And a lot of companies will have no policies whatsoever to begin with. So definitely some cool things you can implement there. Hope you liked this video. If you did, please give it a thumbs up. I will see you again soon. Take care. Bye-bye.